Hey guys, welcome back. We are going to look at day 2 for our Unit 13 notes. We are splitting this, the characteristics of our functions into 2 parts. We're going to look at specifically domain, range, x and y intercepts, max, min, intervals of increase and decrease today. We'll add on the other characteristics on the next day that we do characteristics. We're going to look at all 3 function types. We're going to look at linear functions, we're going to look at exponential functions, and we're going to look at quadratic functions. Now, please remember all this stuff you've seen before, so this is just us going back over, refreshing all this information so that you have it fresh on your brain and remember. We're going to start by giving some definitions or kind of defining each of the following characteristics that we're going to talk about. So, domain. Remember, domain is all possible x values. All possible x values. Okay? Remember, domain always is left, look to the left, and then look to the right. Okay? Either it's going to be in parentheses or it's going to be in a bracket. It's going to be parentheses when we have arrows, and it's going to be a bracket when we have an endpoint. Okay, so it's going to be parentheses when we have arrows, it's going to be a bracket when we have an endpoint, and it's always written from smallest to biggest. So that's the left to the right. Small, then big. Smallest, then biggest. Okay, our range is very similar to the domain, except it's not all possible x's, it's all possible y values. So the only difference is y's don't go left and right. Y values go up and down. So the smallest y value is actually going to be down. So we're going to look down to get our smallest y value. Then we look up to get our biggest y value. Again, if there's an arrow, we're going to use a parenthesis. If there's a bracket, if there's a point, we're going to use a bracket. So the same rules apply for domain and range here. Now, x-intercepts and y-intercepts. Remember, these are points. This is an ordered pair. It's a point on the graph. So the x-intercept is the point where it touches or crosses the x-axis. Okay? Remember, all of these are going to be written as some number for the x, and then the y value is always a 0. That means it will fall on the x-axis. So some number for the x and a 0 for the y, because that means we're not going up and down at all. We're only moving left and right. Okay? A y-intercept is a point where it touches or crosses the y-axis. Okay? And this time, the x will always be 0, and the y will be whatever number it crosses the the y-axis at. Okay? A max and min. So remember, a max or a min is going to be the highest or the lowest y value. Okay? Sometimes we have none. So answers could be none. That's if we have an arrow going up forever or down forever. Okay? And then sometimes our answer is a number. Okay? Remember, a max or a min, it could also fall at a vertex, which we'll look at again. Okay? Then intervals of increase and decrease. So remember, intervals are intervals, so it's a set of numbers from one number to another number, and where it's increasing is going to be all those values that have a positive slope. So these are going to be the x values where we have positive slope. And these are going to be the x values where we have negative slope. Okay, these are going to be written with parentheses, and we always do the small and then the big. Okay, so anytime you write an interval, whether it's domain or range or intervals of increase and decrease, remember it always has to be the smaller number first and then the bigger number. Okay, so let's go down here and let's look at this first example. Okay, the first example says y equals 2x minus 1. You'll notice all of these are already going to be graphed for you. Okay, I'm not asking you to graph these things. I'm asking you to be able to talk about them, tell me about their characteristics, and all those kind of things. So first, let's identify, is this function linear, exponential, or quadratic? Well, you can look at it one of two ways. You can look at your equation, or you can look at the actual graph itself. If you're looking at the graph, you're noticing that this is a straight line. So if you remember from day 1 lesson, we said straight lines are linear. Okay, now, what I liked to do previously was talk about these ends. Remember, these are going to go 2 directions, up and to the right. So remember my numbers, as I keep going farther to the right, these are going to go towards positive infinity. And as we go up forever, these are also going towards positive infinity because these numbers are going to get bigger and bigger. Down here, at this end where this arrow is, it's going to go down forever. Well, as I go down, these numbers are getting smaller and smaller towards negative infinity. But it's also going left forever because it's going to keep on going. Well, the number's going left forever or towards negative infinity. Okay? So remember, domain is left and then right. Well, we have a left arrow and it's going towards negative infinity. Remember we said arrows get parentheses. My arrow to the right is going towards positive infinity. Okay, so because there's an arrow on both ends, that means it's going forever to the left and forever to the right, which is what this says. Forever left, forever right. Okay, the range, remember, so those were x's, the range are y's, so that means we need to look down and then up. So when we look down, well, this graph is going to go forever down, so that's negative infinity. And when we look up, the graph is going to go up forever towards positive infinity. Okay, now we're going to look at x-intercepts and y-intercepts. So remember, x-intercepts we said are ordered pairs, so it's a point where it touches or crosses the x-axis. This right here is the x-axis. Okay, so we are saying, look, it touches right there. So I need to know what that point is. Well, okay, I can guess, but since I have an equation, I can really find out. X-intercepts always have a y value of 0. So if I happen to put a 0 in place of the y of the equation, I'm going to find that I could solve for this x. So if I add 1, I get 1 equals 2x, and then if I divide by 2, we're going to get 1/2. Well, I probably could have guessed that that was going through 1/2, but I just wanted to make sure so I knew I was using the right value. Again, 1/2, if you want to use 0.5, that's just fine because it's the exact decimal. Okay, y-intercept, we said our y-intercept is a point that crosses the y-axis. So remember, this is my y-axis, the vertical here. So I need to know what that point is. To me, it looks like it's a -1, but I want to make sure. So remember, the x is always 0 on this. So if I put a 0 in place of x, I get that the y is going to be -1, which is what I thought it was. Okay, max and min, okay, if this thing goes up forever and down forever, it will never get to the highest point. So this is going to be none, and I'm going to put off on the side because of the arrows. Okay, because it goes on forever, you need to make sure you know that it will not have a max or a min. Then intervals of increase and decrease, remember this is talking about positive slope, and this one is talking about negative slope. Well, this graph right here, if you put your pencil on it, you'll notice that this is moving in a positive direction. It's going up and then to the right. If you're looking at your equation, you can look at this number and say that's a positive slope because that's our m. So that means this whole function is a positive slope. So that means we have none for the intervals of decrease, but every single x value, because remember, intervals of increase and decrease are x values. Well, let's talk about the x's of this function. The x's go from negative infinity to positive infinity. So it's the whole function, every single value. Okay? We're going to go through the next one a little quicker. It's another linear. Okay? Except this one is going downward. It has a negative slope. Okay? So again, I said this one is another linear, so I'm going to go ahead and put that. This is linear. My domain is forever left to forever right. And I know that because this arrow goes forever left, and this arrow is going to go forever right. So negative infinity to positive infinity. The range, remember those are my y's, so I need to know that this one's going to keep going down forever, which is negative infinity, and this one is going to keep going slowly up forever towards positive infinity. Okay? X-intercepts and y-intercepts, so remember, my x-intercept will always have a y of 0. My y-intercept will always have an x of 0. Okay? I can use my equation because right here it's kind of hard to see. I'm thinking it's going to be a 6, but I want to just double check and make sure. So my x-intercept, I'm going to put a 0 in place of the y. So I get negative 1/3 x plus 2. So if I subtract 2, okay, to get rid of this fraction, remember, I can either divide by that fraction, but it's easier to multiply by the reciprocal. So I'm going to multiply this side by negative 3/1, and I'm going to multiply this side by negative 3/1. So that makes those go away. X is going to give me negative 3 times negative 2, which is a positive 6/1. So that was indeed a 6. Go me. Okay, now I'm going to do my y-intercept. It looks like it's going through a 2. Okay, I'm pretty confident that I can say that that's a 2, but let's just check. So for y-intercepts, my x is always 0, so negative 1/3 times 0 plus 2. Well, 0 times anything is 0, so that is going to give me a 2. Okay. On this one, because there's an arrow on the left side and the right side, that means it's going up forever and down forever. So that means we will not have a max or a min, so none. And then my intervals of increase and intervals of decrease, well, this is a straight line, so it's either all going to be increasing or all going to be decreasing. Well, look at it. What kind of slope is it? It's a negative slope. I knew that from this as well. It was a negative slope, so that means this whole thing is decreasing. So there is none for the interval of increase, and the whole function, every single x from negative infinity to positive infinity, is going to be decreasing. Okay? Now, let's move on to the next page. So we're doing the exact same characteristics, except this time we're looking at a different type of equation. So first let's identify what kind of equation this is. This is, well, look where your exponent is. Okay? Or look at your type of graph. You'll notice this is a curved line and your exponent is your variable. So that means this is exponential. Okay? So let's talk about domain. Domain is left and right. Well, look at the left side. This is going to go forever left. This is also going to go forever right. So the domain of this is negative infinity to positive infinity. The range of this, remember range is y, so we're looking down and then up. Okay, be careful. This is going to go down forever, but is it going to ever cross this special imaginary line that we called our asymptote? Oops, asymptote, there's a P in there, or an M in there. Okay, remember this is just going to get closer and closer to this imaginary line here called our asymptote. So please remember the exponentials, we're going to approach an asymptote and it's going to be somewhere in our range. So this asymptote is always a y value. This y value here is 0. So that means my range is going to be closer and closer and closer to 0. This means but not touching it because there's an arrow. And then it's going to go up forever to positive infinity.